So now we know that what is linear number sequences. So it's time to talk about non-linear number sequences. So non-linear number sequences is the difference between terms increase or decrease in different amount. That means finding the formula for non-linear number sequences are not going to be easy. We need to find out each formula by ourselves. So for this, I'm going to introduce you a special number sequences as well. So when you see the sequence, please focus on each numbers and figure out what types of numbers, alright? So let's get started. Now, look at these numbers. Let's find our common difference first, but they definitely don't have common difference, right? So let's see. Plus 3, plus 5, and 7. Oh, it has got pattern anyway. There's no common differences, but it has got pattern. Then let's see, how can you find our formula? But let's focus on each numbers. 1, 4, 9, 16. I think I'm familiar with these numbers. How about you? All of these numbers are all square numbers. So this number sequence is called the square number sequences. And the square number means, you all know that, right? Numbers that can be multiplied by themselves. So now, let's find our 20th number, the 20th term. Then let's have a look at this one. Your first number is 1. So like linear numbers, our final goal is we need to looking for our formula, right? The first number is 1 times 1. Since all of these are square numbers, so 1 times 1, your second, when your n is 2, your number is 2 times 2, 2 squared. Your n is 3. Your third number is 3 times 3. Your fourth number, when n is 4, your number is 4 times 4. Then now, for our formula, nth term, nth number, how can you write down this pattern as n? Yes, n times n. That is our formula. So I'm going to write down nth term as n squared, since this is a square number, right? So we found our non-linear special number sequence. That is a square number sequence, and the formula is n squared. So when you find the 20th number, your n is 20, just put 20 inside the n. So 20 times 20 gives you 400. Then, if I ask you a question like this, what is your 100th square number? Don't writing down all the square numbers, then count up to 100. So, we've got a formula, square number sequence is n squared. Then, nth 100th square number, that means your n equals 100. Then, our formula n squared, then 100 times 100. That gives you 10,000, right? So 10,000 is 100th square number. Now we've got another number sequence. Then we need to find the 20th number. Have a look at numbers increase dramatically. 7, 19. Then, it's really hard to figure out the pattern. Then I don't know how to find the pattern. Then let's focus on each numbers. 1, 8, 27, 64, 125. Is getting familiar with these numbers. All of these numbers are cube numbers, right? So this is called the cube number sequence. I really want you to recognize these numbers. Then, now let's find our formula for cube number. So the same as the square number. Let's see, we need to find the patterns between the n and the numbers. First number, when your n is 1, then cube number, that means you times 3 times. 8 is your n is 2, 2 times 2 times 2. 2 cubed is 8. And third number, your n is 3. 3 times 3 times 3 times, that gives you 27. Your n is 4. 4 times 4 times 4. 4's cube is 64. So your nth term is, our formula is n times n times n. So now our nth term, our formula for the cube number sequence is n cubed. So now let's find our 20th number. 20 means your n is 20. So let's put 20 times 20 cubed means 20 times 20 times 20. So 2 cubed is 8 and you add up 1,000. That gives 8,000. Then again, if I ask you to find what is the 50th cube number, how will you do it? Don't write down all the cube numbers. Please use our formula that is n cubed, and your 50th number is your n equals 50, right? Just put 50 inside the formula. So n cubed means 50 times 50 times 50. So 3 cubed is 125, and so that gives you 125,000. Now, sometimes you can see your number sequences with the pictures. Let's have a look at how many circles can you see in each term. Let's find the sum of the circle. So first one, you can see 1 circle. Second one, let's count. Top row, you've got 1. Second row, you've got 3 circle. Add up is 4, right? And your third pattern is the same. Just focus on your bottom row. So you add up 5, right? Then your fourth pattern as well. So same as the third pattern. Then 1, 3, 5. Then you just add up the bottom one. That is a 7. So 1 plus 3 plus 5 plus 7. Now, can you write this as an answer term? What did you notice that? Let's find our pattern. So it looks like let's add up. Let's find the sum. It's 1, 4, 9, 16. Ooh, you remember all of these numbers are? Yeah, we just did it before. 1, 4, 9, 16 is square numbers, right? So this number sequence is a square number sequence. So our n stem, you always remember square number sequence formula is n squared. Then our nth term is, I'm going to write down n squared. Then, interestingly, this number sequence has got another name. That is sum of odd number sequence. Because have a look at all the numbers. You add up, keep adding up your odd numbers, right? So 1 plus 3 plus 5 plus 7, and your next term will be 9, right? That gives you 25. Again, 25 is a square number. Wow, it's very interesting. So square number means it's at the same time it's a sum of your odd number as well. So whenever you see odd numbers adding up together, then you think of a square number. So now in here, identify your n is important. So sum of odd numbers, your n means how many odd number you add up. That's very important. Remember, when it comes to the odd number pattern, that is the same as a square number, but n means number of odd number. Let's have a look at this one. What is the sum of all odd number less than 100? If you got this question, how will you solve? So again, we need to use our number sequence knowledge. So now thinking about it, we know that sum of odd number is the same as a square number, right? So now all we need to do is we need to figure it out. What is n? The nth term will be n squared, right? Then what is n? How many odd number you add up to 100, right? So figure it out. How many odd numbers can you see less than 100. This is not tricky. Think about it. From 1 to less than 10, how many odd number and how many even number you can see? 5 odd number and 5 even number. So numbers from 1 to less than 50, how many? You've got a 25 odd number, 25 even number, right? Then the numbers from 1 to less than 100, we definitely can see 50 odd numbers and 50 even numbers. So numbers less than 100, we can see 50 odd numbers are there. That means your n is 50, right? So that means we need to find the 50th pattern. So use your formula n is 50, then your formula is n squared. So 50 times 50, it gives you 2,500. So just remember, sum of all of 50 odd numbers from 1 to 99, it gives you 2,500. And sum of odd number patterns is exactly same as a square number pattern. Now we have a new number sequence. Let's try to figure out our pattern. So you need to find the formula by looking at the difference. 2, 3, 4. Oh, it looks like it has got a pattern, right? So keep adding consecutive numbers from 2, right? Then now how can you find our pattern? So first number is a 1. Then second number is a add the previous number to 2. So 1 plus 2, it gives you 3, right? Your third number is copy the previous number. 1 plus 2 plus 3 gives you 6. And fourth number is 1 add 2 add 3 add 4. That gives you 10. It looks like we're adding up all the consecutive numbers from 1. I'm going to just let you know the name of this number sequence. This is called the triangular numbers. Then why this is called triangular numbers? I will show you. So I'm going to draw some circles. Our top row, just put the 1 circle. Then our second row, let's add up 2 circles, and then that gives you 3 circles, right? Just thinking about the sum of the circles as well. And now I'm gonna add up 3 circles and add all together is 6. Add up 4 more circles that add up to 10. The next one, add up to 5 more circles and it gives you 15 circles all together. So look at these circles, it form the triangle. That's why this number sequence called the triangular number. Then finding nth term is super tricky. But at least we can see the pattern. We keep adding the consecutive numbers from 1, right? So now how to find the nth term of triangular number is, don't just simply memorize it. You need to understand how we come up with the formula. So let me say my nth number. I'm looking for nth number. So my n is 4. I'm looking for what could it be nth term. Then what I can do is I'm going to draw the circles. So always triangular number add up from 1 to 4, right? So I'm just draw the circles. 1 plus 2 plus 3 plus 4. I'm done. Now what I'm going to do is I copy down this triangle but upside down. I'm just copying down the triangle but upside down. So top row 1, 2, 3, 4 because we are looking for nth term. Then what did you notice? What shape is this? This shape is a parallelogram, right? You know, just think about when you find the area of the parallelogram, you need to think about how many 1 centimeter unit square you have, right? So let's consider that one circle is a 1 unit square, then if you find the area of the parallelogram, that is the same as the numbers of the circle, right? So let's see, your height is, you've got a 4 rows, that's why your height is 4, that's n, right? And your base is 1, 2, 3, 4 plus 1. So I'm going to say this is n plus 1, right? So let's calculate the area of the parallelogram. That is always base times height, n times n plus 1. But remember, we are not looking for the parallelogram, right? We need to focus on our triangle. This is our nth term. How many circles inside the triangle? So we need to focus on the area of a triangle. How can you find the area of a triangle? Just simply divide by 2, because the parallelogram is made two identical triangle, put them together, right? So can you see all of these red circles? That is our nth number, right? So now we've got a formula. So n times n plus 1 divided by 2. That is nth term of a triangular number. Yeah, I know this is tricky, right? But I just don't want you to remember. Just memorize n times n plus 1 divided by 2. No, it's always, you need to understand why we have got this formula, okay? So now once you remember the process, you clearly understand how we get this formula, then you can memorize it and use it. So now let's find our 19th number, 19th term. That means, so you keep adding up the numbers, consecutive numbers from 1. What could it be? The sum of all the 19 numbers, that is n equal 19. Then let's use our formula. 19 plus 1 more than 19 is 20, right? Just 1 more than, then divide by 2. That gives 19 times 20 divided by 2. So 2 and 20, you can simplify it. Then 190 is the nth term. That means 19th number. That means if you add not all the way numbers from 1 to 19, you add up all these numbers, it gives you 190. How about 99th number? So that means your n is 99. So let's put that 99 into n. 99 times 1 more than 99 divided by 2. That gives you 99 times 100 divided by 2. And we can see we can simplify by 2. Then 99 times 50 is, so 4,950. That means all the way through, to add up the number 1 to all the way 99, add up all together, it gives you 4,950. Don't just add up all these 99 numbers. Just simply use our formula for triangular number. Alright, so far we focus on the non-linear number sequences, and this is not easy to find the formula. That's why I introduced you the special numbers, right? So can you remember all the special number sequences? The first one was square number, then formula is n squared, and second number sequences was a cube number sequence, and then formula is n cubed. And then now we also know that sum of all the number sequence is the same as the square number, and the difference is n means how many odd number you add is n, right? Then finally we've been talking about the
triangular number.
Is you adding up numbers from 1 to n, right? All of the sum is
Triangular number.
Then the formula is n times n plus 1, then divide by 2. So now once you understand the formula, please memorize it. Then next lesson I will introduce you more non-linear sequences, and I will see you at next lesson. Bye.